Hello, guys and girls. Mr. Hescox coming back to you, my 8th grade physical science kids. Your warm up question of the day: what happens to the boiling points of solutions when a solute is added? When you add a solute, the boiling point should go up. So if water boils at 100 degrees Celsius, you add some salt to the water, it may boil at 102, 103, something higher than what it would usually do. The topic of today is what is solubility, and the reading is 245 to 251. Homework will be the review 8.2. The amount of solute that can dissolve varies. Now that means it changes. Now, depending on what the solvent and the solute is. Some types of solutions will have a very high concentration. In other words, they have a large amount of solute. So this is what I like to call the sweet tea. You can buy sweet southern tea, and then you can buy super sweet tea. Now, the more sweet or the more sweet it is usually includes a higher concentration of sugar. A solution's concentration depends upon the amount of solute dissolved in the solvent at a particular temperature. The more sugar in the water, the stronger the sugar taste in your tea or lemonade. If it's not got a lot of sweetness to it, we would say that it's a dilute. If it's very high, you could say that it might be saturated or very concentrated. Now, when it comes to degrees of solutions, dilute means having a low concentration. The water in our area is very dilute when it comes to salt. There's a little bit of salt in the water in the streams and rivers, but very, very low. So you'd say that that's a dilute solution. Um, Now, saturated solution is one that is holding the maximum amount. I like to think about a saturated solution as a bucket that's full of water all the way to the top. If you add one more drop of water to that bucket, what's going to happen? Some of it has to drip out. Now, then there's one called supersaturated. Supersaturated is only formed when you heat a liquid, add more solute than you would normally be able to get to dissolve, and then allow it to cool. We call that supersaturated. So these are your super sweet teas. Growing up, my grandmother used to make tea on the stove all the time, and she would boil literally a whole cup of sugar in a pan of water till it was super dissolved, and then add her tea in as it was boiling. It was super saturated because at the lower temperature that you like iced tea at, it should not have been able to support that much of the solute. Solubility is the amount of substance that can be dissolved in a solvent at a given temperature. If the solute has high solubility, the solution will have a high concentration. Sometimes you get a low solubility and then you get a low concentration. Make sure you guys watch the bear video on polar and nonpolar. Be cute. This graph here shows the solubility of some very common solids. So you've got salt, this is sodium nitrate, this is potassium nitrate. As the temperature goes up, as this temperature slowly works its way up, the solubility goes up. Notice how fast the solubility of the potassium nitrate goes up. It jumps really, really fast. But all three of those solids, as you increase the temperature, they all increase. So as the temperature gets warmer, you can dissolve more in the same amount of solvent. Now, the exact opposite happens in a gas. So solubility happens because as the particles are bouncing around, those little particles bounce into the particles being dissolved in a liquid and they suspend them. Gases are already wanting to bounce around. So to keep a gas in solution, you have to cause the temperature to decrease. As the temperature goes up, here our solubility is actually decreasing. With every single one of these, as the temperature is going up, temperature's down here, the solubility is decreasing of these gases. So you've got nitrous oxide, oxygen, carbon monoxide, methane, and nitrogen gas. Every single one of these, you have this descending solubility. So solubility, solubility of the gas goes down as the temperature goes up. We can change the solubility by doing some different things. So we can change the temperature of and change the solubility. We can change the pressure. When you add pressure and then you seal a bottle of soda, you get that gas buildup that keeps the bubbles in. You can stir and increase solubility. Like if you're at a restaurant and you get unsweetened tea and you add some sugar to it, well, what do? You help it to dissolve by stirring it and causing the particles to speed up. Um, Increasing the pressure of gas solutes, putting more pressure on them. That when you open up a can of soda, that's the pressure being released. The moment you hear that and you hear that air coming out, that's carbon dioxide gas being allowed to release from the solution in your soda. That carbon dioxide gas will go out of your soda. If you put the soda, once you open it in the fridge, you can keep some of that carbon dioxide gas in longer than if you let it sit out on the counter at room temperature. So will this increase or will this decrease the solubility? So here we have a liquid. Here I am stirring the liquid. Will that increase or decrease the solubility? There you have it. Stirring will increase solubility. We cause these particles to speed up, causing more collisions. Here I'm heating water in a pot. Heating will increase the solubility of a solid, so you could add more sugar. But if you were trying to get the carbon dioxide out of this, if this was soda, you would be causing the carbon dioxide to decrease. That is a deep freeze. If you lower the temperature, you will lower the solubility of a solid, or you can increase the solubility of a gas. Now, not if you completely freeze it, but if you lower the temperature of a liquid, you can either cause the solubility to go up if it's a gas, or if it's a solid, that solubility will go down. There you go. Open a bottle of Coke. Releasing the pressure reduces the solubility by reducing the amount of pressure once you open that cap. You can now allow that extra pressure off. All right, guys. So now we've talked about solubility and some ways that solubility affects us with increasing and decreasing. That ends this section. Make sure you get your reading done for me. Make sure you watch all of the little videos. And until next time, I'm Mr. Hescox. You be good, be safe. See ya.